So,
Okay. Are you busy with something?
I came back from work and I am very, very dead.
That is what I asked you the previous day when we were figuring out what time should we meet. But you said that you will be okay with it, like you should be back from work within that time.
Yeah, just they had to keep me back for another hour.
Okay. So I think you got extra payment as well, right? So that's good.
Pretty much, yeah. Extra
Okay.
money to get rich.
All
So,
right.
yeah.
So we were discussing about like logarithms and indexes previously, but I am trying to take a shift into chemistry now
Okay.
because your exams have ended, and we will continue to math again. What is about that?
Okay.
So we were discussing at the very last class of chemistry. I think the ionic compounds and their solubility, right?
I think so, yeah.
Okay, and okay, so these pages we have completed. Okay. All right, tell me, did we learn how to name ionic compounds?
I think so.
Yes, yes, you're right.
You had a
Okay.
long talk about chloride and chlorine and
Yes.
etc.
Okay. Okay, so did we complete these? Okay. All right. Actually, start from naming as well. Again. Okay. So how do we name the ionic compound? Actually, in case of ionic compounds, we get two parts, right? What are the two parts?
Yes.
One is the cation, and another one is the anion. Okay.
Anion.
And based on their valencies, they have different names, and obviously based on what elements they are, they have different names as well. Okay. Say for instance, sodium. Sodium will, uh, I mean, 99.9% of the time will form this cation, which is Na plus. The name of this ion is sodium ion. Okay, sodium ion. So notice when we are forming a compound involving Na plus and another anion, it will have the sodium in name. Because why? Na plus is sodium. That is why. Say for instance, if I say to you like Na2SO4. Okay. So what should be the name of this?
Sodium sulfate.
Sodium sulfate. Why? Because the SO4 is sulfate here and sodium is sodium. So like in that way,
Yes.
we also learned copper 1 ion, then copper 2 ion. Like what are the ions? That's the most important thing. Okay. Say for instance, if I would have given you Na2S, what would the name have been? What would be the name?
Sodium sulfite.
Sulfide with a D, right? With a D. Okay.
Yes.
Sulfide. And in case of Na2SO3, it will be sodium sulfite. Sulfite. So that is how the
Okay.
names change. You have to remember that if a particular element has, numerous valences, like more than one valency, then you have to figure out uh, which one should you use. Otherwise, you will, name it wrongly. Say, for instance, you are even with something like copper sulfate. Okay, so you have to say that it is copper 2 sulfate. Okay, copper, and in bracket you write 2, then sulfate. If you write 1 here, that will be a wrong. Okay, wrong thing. Okay. So in this way, you have to like remember all the valencies or all the ions that a particular element forms, and obviously as we have learned the electronic configurations of 1 to 30, uh, the 1 to 30 atomic numbered elements, so that makes it easy for us to understand what will be the like anions or cations that a particular element will form. Okay, so that's a brief discussion about that. And So copper sulfate in this way, and okay, let's see ionic equations. So what are ionic equations? You will learn about that more when we study redox reactions. But let's see at this level what we have. Okay. So ionic equations are often used to summarize chemical reactions. An ionic equation shows the ions that participate in a chemical equation. An ionic equation can be written for neutralization and precipitation. Okay. So what is a precipitation reaction? In this case, we can see that something gets precipitated, or some solid compound would be found after the reaction has been formed. Okay. Say for instance, what could be an example? Okay, what happened there? That is not what I want. Okay, do I have to find the page again? Okay, 1 second, just a second. 12.4 it was. All right. So what I was saying was precipitated. In case of something, say for instance, like say I am working with something like I don't know if this equation will work or not. Just as an example, I'm saying, okay, how could precipitation reactions work? NaCl plus silver. Okay, okay. So in normal scenario, what? Oh, sorry. Okay. He for silver. You know, there was an activity series. Okay, activity series. That is what I'm trying to memorize. I figure out. So activity series represents that what sort of elements can replace another element. Say for instance, if I give you a very easy example, say for instance, say I have AgCl, okay. AgCl, and I have sodium. Okay. So now sodium is more active than silver. That means that sodium can replace silver. Okay, sodium can replace silver. So I will get NaCl plus H. Okay, understand what I'm saying?
Isn't that another type of like reaction?
Isn't it another type of reaction? Yes, I mean I'm showing you a particular reaction where anything gets precipitated. Okay, so say for instance here what you will see is that silver can be seen at the very bottom after the reaction has been formed. Okay, so that is what I was trying to say, like a precipitation reaction. Okay.
Oh, okay, makes sense. Yeah.
All
That's
right,
single replacement, I think.
and we will study about the activity series as well, like which compound can replace another compound. Like if you write, say for instance, sodium chloride plus copper. Okay, so then you are writing something like copper chloride plus sodium. Okay, so this is wrong. You will get a 00 if you write this, because it's not possible for copper to replace sodium. Okay, because copper is less reactive than sodium, or lies in like at the very bottom of the activity series. Okay, so because of that, copper cannot replace the sodium. If I actually show you the activity series as well to you, activity series. See, this is a very all right. See, potassium, sodium, calcium, magnesium, aluminium, carbon, zinc, iron. I think I have showed you before as well, I guess.
Yes.
All right. So see, in case of like replacing, like if you ask me that Bhaiya, can lead replace copper, the answer is yes, because lead is more reactive. So it can replace a less reactive element. But can copper replace sodium? The answer is no. Okay, so you have to like remember it, and maybe these sort of like poetic words could be used as well. Otherwise, it's really difficult to memorize. Okay, all right. I used it in Bangla. Okay, so for me it's difficult to comprehend these poems in English, and even if I provide it to you, it might not be friendly to you. Okay, so now let's get back to where we were. So now a neutralization reaction occurs when an acid such as hydrochloric acid is neutralized by a base. Okay, and then we will get neutral compounds such as salt and water. Okay, in case of a reaction between acid and a base, we will get neutral compounds. Okay, so for instance, if I like generalize the equation, it will be something for a reaction into acid plus base, and I will get salt plus water. Okay. Acid plus base will be salt plus water. And okay, we will discuss it later. So acid has a pH value of less than 7, and base has a pH value of greater than 7. But whenever you are forming like salts and water, if these are pure salts and pure waters, they will have a pH value of 7. Okay, we will discuss it when we study about acids and bases. Okay. All right. So solution of HCl, and in between that, we can see that ions have been distributed like H plus ions, chloride ions. And whenever we're adding sodium hydroxide, these will be distributed as sodium ions and hydroxyl ion as well. Now, as we know that positive attracts the negative, what will happen is sodium will bond with chloride. And tell me another, how has sodium been able to replace hydrogen? Why is it so?
Sodium is more reactive than hydrogen now.
Right, exactly.
Yeah.
So sodium is able to replace hydrogen, and then sodium chloride is formed, and then also water is also formed. Okay. So H2 molecules formed from the reaction of positive hydrogen ions with negative hydroxide ions. Okay. And also for sodium chloride, sodium plus ion, and chloride ion. So these are like very easy things, not that much difficult. All right, so balancing equations. In case of like if there are no changes in valences, what you would find out is that you don't have to like balance anything at all. Okay, say for instance, hydrogen, chlorine, sodium hydroxyl ion, each and every ion here has a ion of +1 or -1. Okay, so that is why you don't have to like form any balancing. But in case there are like various valences involved, say for instance, if I write like, say for instance, sodium hydroxide plus H2SO4. Now then, obviously you understand that sodium sulfate plus H2 would be formed. But here you have to do some sort of balancing. Why? Because see, sulfate has a valency or like charge of -2. Hydrogen has a charge of +1. Hydroxide is a -1. Sodium is a +1. Okay. So all the charges are not same here. That is why we will have to perform some sort of balance. And how to balance a particular equation or reaction, we have learned that previously, right? Okay.
Yes.
Also, this one is easy as well. So, like all the elements have, or the what can I say, composite ions have the same number of ion or charge. So, what are they saying? Ionic equations from precipitation equation. Okay, fine. So here you will have to form the ionic equations. We are somewhat getting into like oxidation reduction reactions, somewhat, not all of it. So say for instance, forget whatever they have written here. Let us try to examine by ourselves. So lead nitrate plus potassium iodide, and we've got PbI2, lead iodide, and plus 2 KNO3. This is an aqueous solution state. This is a solid state. This is aqueous solution state. This is also aqueous solution state. Now, what you have to do is, first of all, identify the ions that are present. Okay. Say, for instance, for lead nitrate, tell me what are the ions which you can like figure out. What do you think? What are the ions here?
The iron. Plum bum.
Yes. So
Sorry.
I mean, what will be the charge?
I'm guessing that would be +2.
+2, right? And another ion?
The nitrate will be -1, but yeah.
-1. Very good. And in this way, +1 and -1 as well.
Yes.
Again, in the right side, we will get +2, -1, and then +1 and -1. Okay. So, okay, so this won't be a oxidation reduction reaction. Why? Because in case of oxidation reactions, what happens is that you will get a particular change in charges. Like for instance, in the left side, you would see like lead has a +2 charge. In the right side, it would change to +4. Okay. Again, in case of the left side, you are seeing that iodine has a -1 charge, and in the right side, it's forming a +7 charge. For instance, okay. So that won't be an oxidation reduction reaction, but we can now easily write it into a ionic equations. How do we write it? We will write it like Pb2 plus NO3 minus. But how many NO3s do we have?
2.
We multiply it by 2 plus K plus I minus. Then we'll write again Pb2 plus 2I minus. Okay, this will be multiplied by 2 and then 2 as well. 2I minus plus 2K plus 2. Now you might as well ask that what's the change between the left and right side? You can see the changes between the arrangement of the ions. We have written lead ion and nitrate ion together in this case, and potassium and iodide ion together. And in the right side, we have written lead ion and iodide ion together, and potassium ion and nitrate. That is the basic change. That is what I think so, but let's see if they have changed anything. Okay. So let's see. Pb2 plus. Oh, okay. So what they have done is they have just formed the equation for the particular compound which is getting precipitated. So in this case, PbI2 or lead iodide is being precipitated. So for that, what should be our like ionic equation? Tell me. We've written all of it. What should it be?
Ionic would
I mean, see, we have like distributed into ions all of the compounds. Okay, all the compounds like lead nitrate is distributed like this. Okay.
yes.
And potassium iodide is distributed like this. So how will you distribute lead iodide?
PbI.
We have already figured out the charges. Okay, we have already figured out the charges. Okay.
So what do you mean by the?
Okay. I try to simplify it to see. Say for instance, you can see that. Okay, forget about the right side. Okay, forget about the right side first. Let's say we have only the left side. Okay. So if we like distribute all the ions in the left side, what do we get? that is lead 2 plus from here, then NO3 minus from this portion and multiplied by 2 because of 2 NO3s are there, and 2K plus and 2I minus because 2 potassium ions and 2 iodide ions are there. Okay, now my question is, in the right side you are getting a solid compound. Okay, solid compounds means that it has been precipitated. Okay, so which ions together will form this PbI2 or lead iodide?
Plus 2 plus ions, like cation and anion.
Yes. Okay. What is the cation here? Lead iodide.
Plumbum.
Yes. So Pb2.
Lead, sorry.
And then
Iodide.
Iodide. Then iodide minus, and here we will see a
-1. Yeah.
And just write PbI2. There, that is it. Okay. So we did we did it the hard way first, and this is the easy way. That is it. This is
that
your
makes
answer.
so much sense.
Okay. All right. So very easy. Very easy. Okay. All right. But in case of like oxidation reduction reactions, you will have to consider all the ions. Not like they won't tell you that write down the oxidation reduction reaction for the solid compound in the reaction. No, they won't tell you that. Okay. Because the main reason behind it is that whenever a reduction reaction occurs, the oxidation reaction will occur as well. Okay. And one particular element would not get involved in oxidation as well and reduction as well together. Okay. We will discuss about that later. But for now, that is what your book is trying to suggest. That is what I said. Okay.
Good.
Right. Check that the change on either side of the equation is equal. Yes, it is equal. Okay, all right. All right. Now, tell me what should be the equation for silver chloride?
Ag +3.
+3. Why
Sorry. Silver plus. Is it +1?
Yes, +1. Silver does not. Silver does not have I mean, a charge of +3. It has a charge of +1 only. Okay.
Wait, it's an alkaline. It's an alkaline metal.
It's not an alkaline metal, but it's not necessary that all the elements which have the charge of +1 have to be alkaline metals. Okay. There you would find other elements as well who have like +1 valency, but they are not alkaline metal. Like in, say, for instance, aurum or gold. Okay, gold has a charge of +1 as well. Okay,
Oh,
they are
that's
not.
so cool.
Again, say for instance, the lead is lead like, what is it called? Like alkaline earth metal? No, lead is not an alkaline earth metal, but it has a charge of +2, right? I understand your point. So it's not necessary that if anything has a +1 charge, it has to be a alkaline metal. Okay. All right. Now tell me what should be the equation?
Where is it? Where is it? Where is it? Okay. Silver plus C plus chloride -1 equals AgCl.
Yes, that's it. That's it. Very, very easy. All right. Okay, so now what they've shown here is like they have written down all the ions at first. Okay, all the ions at first, but the ions involved with like the precipitated compound they have kept, and the ions that are not involved with the precipitated compound they have just ignored them or cancelled them. Okay, so this is how you can form it as well if you don't get the idea of what should be the ions. So this would be another way as well. Okay, so whichever way you feel comfortable, but I guess if you write it like direct, the teacher should give you full marks for it. Okay, if I were the teacher, I would have given you the full marks, because you are able to understand this particular thing by jumping all the steps. That means you have a firmer grip over these steps. All right. Okay, how ionic compounds dissolve in water. Okay. So now water is a like polar compound. Okay, what does polarity mean? Tell me, what does polarity mean? What do you think?
It's able to.
Have you heard the term bipolar disorder?
Yes.
Bipolar disorder. So what, like I don't know the medical terms and all, but what it means is like at two like different situations, the person will act like two different persons. Okay. Say for instance, say name two of your like favorite celebrities.
Pardon?
Two of your favorite celebrities. You have any?
I
Anyone,
have
it could be a
no
sports
clue.
person or anything.
Adam Sandler and Kobe Bryant, I guess.
All right. So, say for instance, there is a particular boy named, what can I say? A particular boy named, say, James. Okay, James. So now, what happens is he has developed some kind of a disorder because of what? What happens is that whenever he goes into a basketball court, he acts like Kobe Bryant, and whenever he's outside the basketball court, he acts like Adam Sandler. Just an example. Okay. So, in case of like polarity as well, at one part, you will see a negative portion, and at another part, you will see a positive portion. So, if we like draw the structure of water, it will be something like this. So, hydrogen here, oxygen here, and hydrogen here. Okay. So oxygen will be partially negative and hydrogen will be partially positive. What did I say? Not negative, not positive. I'm saying partially negative and partially positive. So in between a compound, you are seeing that compounds are meant to be like, what can I say? They are neutral, right? Obviously. They're neutral. Compounds are always neutral. Say sodium chloride. Okay. Yes, this is an ionic compound, but it's like the ions between them are balanced. Okay. But in case of like the compounds which have been formed by covalent bonds, what happens is, do you remember studying like electronegativity?
Yes.
So the electronegativity of oxygen and hydrogen is not the same. Electronegativity of oxygen and hydrogen is not the same. So because of that, say oxygen's electronegativity was, I don't particularly, I might not be correct. It could be 3, maybe 3 or 3.5. I think 3. And hydrogen's electronegativity, that is, I'm sure, 2.1. So that means oxygen has the, I mean, more capability to like, what can I say, snatch the shared electron towards it. Say, for instance, if I show it to you like this, say, for instance, this is hydrogen, this is oxygen, this is another hydrogen. This is hydrogen. The schematic diagrams, because obviously hydrogen is not the same size as oxygen. You obviously know the oxygen. Now these electrons will tend to get towards the oxygen's area. Okay. Why? Because oxygen has the higher electronegativity. That is what this whole thing implies. Okay. So because of that, oxygen becomes partially negative and hydrogen becomes partially positive. Okay. And in between a same compound, we are saying electronegative side and also a electropositive side. Okay. So this phenomenon is known as polarity, or as they are saying, ion like dipole. Okay. Polarity or dipole, you could say dipole. Okay. Now, in case of like say for instance, a particular ionic compound which is like getting mixed with water, which is a polar compound, what will happen? So a very interesting thing happens. See, I don't even have to draw it now. It's already given here. See, sodium plus iron. Okay. So it will react with or get attracted with the oxygen negative, partially negative ions. Okay. Oxygen partially negative ions. Okay. And these oxygen partially negative ions are obviously connected with hydrogen partially positive ions. Okay. So that is how they are like getting attracted and getting distributed into water. Okay. And they are getting mixed with each other. But it shouldn't be the only case for sodium ion. We have to examine for chloride ion as well. In case of chloride ion, what happens? Chloride ion gets attracted with two hydrogen ions, okay, and the hydrogen ions get attracted with oxygen ions. So in this way, they particularly form this sort of a structure, and the whole sodium chloride compound gets like distributed into water, and they get mixed with it. Are you understanding my point?
Yes.
A particularly difficult concept, at least at your level, because when I studied this bit, I found it a little difficult. It might not be difficult for you, but okay. So like if I like briefly say to you again. So first things first, there has to be a dipole. What is a dipole? A dipole means that particular compound which will have a in one compound, it will have a partially negative side and partially positive side. Okay, all right. And because of that, whenever an ionic compound is mixed with a dipole or a polar compound, the positive charged portion will get, what can I say, like reacted with the partially negative portion and then distribute as shown in the picture, and the partially positive side will get reacted with the negative portion of the ionic compound, and then they will get distributed as can be seen in the picture. Okay, so that is like briefly, you can write it in your own words, and I'm pretty sure whenever like it will be studied in your school, there's a high possibility that your question setters will give questions from this as well. Okay. I mean, these are like conceptual things. The other things like writing down an ionic equations for this is like the schoolboy things. I don't know, they could give that as well. Like, all the questions are not difficult. Okay. All right. So these are like, I think, practical things.
Yeah.
And line. Okay, line of best fit. Have you studied like regressions already?
Yes.
Okay, that's good. That's good. You know, I mean, we I studied regression or correlation at this level, or at least at 11, 12, because I took statistics, which is not a compulsory subject. Okay, we have a separate course outline for statistics. So those students who did not take statistics did not have like farmer grip over statistics. But luckily, and when I am studying now engineering or planning, whatever you say, like I get various courses which involve like high level of statistics, and I just see like other students, they're struggling in finding a good tune over statistics, and I am like easily doing all this just because I have that experience. Why are you saying something?
I was like, ha ha ha.
Okay, so these are like practical things. I think the teachers would show you. I mean, these are like examining. You will see like do the practicals in the laboratory, and you will find out the parts. Okay, so maybe the Australian got awards or something like that. Maybe is what they say. Okay, so these are like questions here. If you have understood, okay, all right. Okay, let me give you another link.
Okay.